Hi students, good morning everybody. In today's lecture, we continue the topic trigonometry first from 11th science. Today we are going to see fundamental identities. Fundamental identities. Now, fundamental identities in trigonometry. So, fundamental identities in trigonometry is nothing but the relation in trigonometry which is true for all possible values of angle theta, or which is true for all admissible values of theta. So that relation is called fundamental identity. For example, see, we have the trigonometric relation sin theta is equal to 1 upon cosec theta, or we have the relation cosec theta is equal to 1 upon sin theta. This relation is true for all possible values of theta. So this sin theta is equal to 1 upon cosec theta. This is called trigonometric identity. So this is fundamental identity. So let's see, identities or fundamental identities are nothing but the relations which is true for all admissible values, or which is true for all possible values of theta, or which is true for all values of theta in the domain. So in particular, sin square theta plus cos square theta is equal to 1. This is fundamental identity. Sin square theta plus cos square theta is equal to 1. This is fundamental identity, because this relation is true for all values of theta. Second one, 1 plus tan square theta is equal to sec square theta only if theta is not equal to pi by 2. Why theta is not equal to pi by 2 here? Because we know that 1 plus tan square theta. See here, this tan theta is not defined for theta is equal to pi by 2. So that's why here theta must be different from pi by 2. So third fundamental identity, 1 plus cot square theta is equal to cosec square theta if theta is not equal to 0. Here, if theta is equal to 0, then cot 0 is not defined, or cosec of 0 is not defined. So that's why theta must be different from 0. So these are fundamental identities. These fundamental identities help us to solve or to simplify the trigonometric relations, trigonometric equations. So this is fundamental identity. Now let's see domain and range of trigonometric functions. Domain and range of trigonometric functions. Of trigonometric functions. So first we see what is domain and what is range. Suppose, see, if y is equal to f of x, y is equal to f of x, this is the given function, then all values of x for which this function is defined. So all values of x are domain of the function, and the values of y are a range of the function. The set of all values of x, that is called domain, and the set of all values of y is called a range of the function. So x are domain and y's are range. Now here we have to see, or we have to find the domain and range of trigonometric functions. There are 6 trigonometric functions: sine, cosine, tangent, cotangent, secant and cosecant. So let's see. We know that if this is the standard unit circle, if this is the point P whose coordinates are x comma y, and let see measure of an angle XOP. This angle is suppose theta. As this is standard unit circle, so this length of OP, consider standard unit circle. Let measure of an angle XOP is equal to theta. So the angle theta has terminal ray OP. So the terminal ray OP intersects the standard unit circle at the point P having coordinates x comma y. So therefore length of OP is equal to 1. We know that if this is standard unit circle, means here length of R is, value of R is 1, length of OP is equal to 1, means length of OP is R. So R is 1 here. And if this is standard unit circle, then by the definition of trigonometric functions, we know that sine theta is equal to y and cos theta is equal to x. So see, length of OP is equal to 1. Length of OP is equal to 1. P has coordinates x comma y. Now this O is origin whose coordinates are 0 comma 0. By using distance formula, we can find the distance between point O and P, and it is nothing but square root of x minus 0 bracket square plus y minus 0 bracket square is equal to 1. That is square root of x square plus y square is equal to 1. Squaring on both sides, we get x square plus y square is equal to 1. Here we know that x square plus y square is equal to 1. It means that minus 1 is less than or equal to x is less than or equal to 1, and minus 1 is less than or equal to y is less than or equal to 1. It means that if x square plus y square is equal to 1, it means the values of x are always in between minus 1 to 1. Also values of y are in between minus 1 to 1. Now here minus 1 is less than or equal to x is less than or equal to 1. But what is x? This x is cos theta. So therefore minus 1 is less than or equal to cos theta is less than or equal to 1, and minus 1 is less than or equal to what is y? Sin theta. So sin theta is less than or equal to 1. It means values of cos theta always in between minus 1 to 1. So values of cos theta means range of cos theta is minus 1 to 1, as well as range of sin theta is here also minus 1 to 1. So therefore the range of sin theta is closed interval minus 1 comma 1. Similarly range of sin theta is minus 1 is less than or equal to sin theta is less than or equal to 1. So sin theta and cos theta have same range. Now the values of theta is the domain of sin theta and cos theta. So sin theta and cos theta are defined for all values of theta, means all values of theta in real number. So domain of sin theta and cos theta is capital R. Capital R means set of real number. So we tabulate the domain and range of trigonometric functions here. Function domain and range. So first, sine function, sine theta. Its domain is capital R, set of real number, and range is closed interval -1, 1. Similarly, cos theta. Its range is capital R, set of real number, and domain is closed interval -1, 1. Tan theta. Domain. Now we know that tan theta is not defined for pi by 2 minus pi by 2, 3 pi by 2 minus 3 pi by 2, 5 pi by 2 minus 5 pi by 2. Means tan theta is not defined for integral multiples of pi by 2. So from the set of real number, from the capital R, we have to exclude, we have to omit those values of theta for whom the tangent function is not defined. It means that we have to eliminate pi by 2 plus or minus pi by 2 plus or minus 3 pi by 2 plus or minus 5 pi by 2 and so on. So your domain is this one, and this can be written as, by using property method, so this set can be written as R minus twice n plus 1 into pi by 2, n belongs to I. N belongs to I. I means set of integer, positive integer, negative integer. And range of tangent function is capital R. Cot of theta. So cot theta is not defined for 0, pi, minus pi means plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. So cot theta is not defined for these values. It means that for these values cot theta does not exist. It means that we have to exclude these values from the set of real number. So the domain of cotangent function or domain of cot theta is R minus n pi, n belongs to I, and its range is also capital R. Cosec of theta, or first we take sec theta, sec of theta. See, sec theta is also not defined for plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, and so on. So sec theta is not defined for these values. It means that we have to exclude these values from the set of real number, and so it is domain of secant function sec theta is R minus twice n plus 1 into pi by 2, n belongs to I. So, and its range is R minus open interval -1, 1. Cosec of theta. See, cosec theta is not defined for 0, plus or minus pi, plus or minus 2 pi, and so the domain of cosec theta is R minus n pi, n belongs to I. N belongs to I means if you take n is equal to 0, so it becomes 0 into pi 0. N is 1 pi, n is minus 1 minus pi. If we take n is equal to 2, it becomes 2 pi. N is equal to minus 2 pi. And the range of the cosec theta is R minus open interval 1, 1. So this is domain and range of trigonometric functions. So let's see next concept, polar coordinates. Polar coordinates. So consider Cartesian coordinate system. Point O as origin. This is x-axis, y-axis. Let P, x, comma, y be any point in the plane. See here, this x, comma, y, these are called Cartesian coordinates of point P. So point P is any point in the plane that we have considered point P in first quadrant. Let length of OP is equal to R. This point P has the distance from origin as R. Measure of an angle XOP is equal to theta. XOP, this angle is theta. Then the ordered pair r comma theta, the ordered pair r comma theta that determines the position of the point P in the plane. The ordered pair r comma theta determine the position of the point P in the plane. The ordered pair r comma theta determine the position of point P in the plane. This ordered pair r comma theta is called polar coordinates of the point P. The ordered pair r comma theta are called polar coordinates of point P. Polar coordinates of point P. Now point O, that is origin, which is fixed, that point O is called pole. The point O is called pole. And OX means x-axis. Point O is called pole and the OX is called polar axis. OX is called, OX means x-axis, is called polar axis. So see, the point P has Cartesian coordinates x comma y and polar coordinates r comma theta. So, see, from the figure or by using the definition of trigonometric functions, we know that sin theta is equal to y upon r and cos theta is equal to x upon r. Now we have the fundamental identity sin square theta plus cos square theta is equal to 1. We have sin square theta plus cos square theta is equal to 1. But just what is sin theta? Y upon r and cos theta x upon r. So it is y divided by r bracket square plus x divided by r bracket square is equal to 1. Now squaring, it is y square divided by r square plus x square divided by r square is equal to 1. Now denominator is same on left hand side, so it is y square plus x square divided by r square is equal to 1. It means that y square plus x square is equal to r square. We have shifted this r square to right hand side. So that is x square plus y square is equal to r square. What is r? R is the distance of the point P from origin. R is distance of the point P from origin. So therefore r is always positive. So therefore r is equal to square root of x square plus y square. Also see here, sin theta is y by r and cos theta is x upon r. So what is of tan theta? You know that tan theta is equal to sin theta divided by cos theta, and that become y divided by x. So with the help of these two relations, r is equal to x square plus y square, square root of x square plus y square, and tan theta is equal to y by x. With the help of these two equations, we can find r and theta, and hence we can write the polar coordinates of the point P. Polar coordinates of the point P are r comma theta. So today we stop it here.